All right, everybody, we are going to go over electron configurations. So for the first one, we are asked to draw an orbital diagram and write the noble gas shorthand electron configuration for bromine. You can start either with the diagram or with the configuration. I typically will start with the diagram because once I have everything drawn, it's really easy to translate it into my code, my string of letters and numbers. And so I'm given bromine. The first thing I need to do is figure out how many electrons I need to count to. We can assume this is neutrally charged, which means my periodic table is my friend. Bromine, when it is neutral, has 35 electrons. So I need to count myself up to 35 electrons. Remember that on the periodic table, I can map each electron to an element as I count up to bromine. So where am I going to start? I'm going to start at 1. I'm going to start at hydrogen. Hydrogen is in the first energy level, and it is in the S block. I can fit 1 electron, 2 electrons in here. 2 electrons total gets me to helium. I'm still not at bromine, so I have to keep going. Where am I going to go next? I'm going to go to the second row, the second energy level, and I'm going to start in the S block. I can fit 2 more electrons there. Still not at 35, have to keep going. Across the periodic table to bromine, carbon, and nitrogen gets me to the p block. Remember that there are 3 p orbitals per energy level. So this is 2p. And I can fit 1, 2, 3, 4, 5, 6 electrons here. This gives me to 10 total electrons. So I'm going to keep going. The next row, I have to go to 3s. I can fit 2 more electrons. That gets me to magnesium. After magnesium, I go across to aluminum. We're back in the p block. This is now 3p. I'm going to fit even more electrons and get me to 18 total. That gets me to argon. I'm still not at 35. I have to keep going. Next is energy level 4 in the S block. Remember, my energy levels map to the row of my periodic table for s and p orbitals. So I can fit 2 more electrons here. That gets me to calcium. The next element is going to be scandium, but that's going to be in the D block. The D block will have, there will be 5 d orbitals in an energy level. But because d orbitals are higher in energy than we expect, that means that the 3d orbital is closer in energy to 4s. And so the d energy levels are 1 behind. Now I can fit 10 more electrons in here. Still not at 35, I'm at 30. I have to keep going. After the D block, I will again return to the P block. This is now 4p, and I'm going to fit my last 5 electrons in here. And that's going to give me the orbital diagram for bromine. Now, if I wanted to write the full electron configuration, I would just go, okay, I have 1s, and I have 2 electrons here. Then I go to 2s, I have 2 electrons here. But we want the noble gas shorthand. The way we do that is we are going to go to bromine on the periodic table. We are going to backtrack to the previous noble gas. The previous noble gas for bromine is argon. Argon has 18 electrons, which means my first 18 electrons in my diagram are accounted for already. Then I just have to list whatever is left over. So I have 4s with 2 electrons in it. I have 3d with 10 electrons in it. And then I have 4p with 5 electrons in it. And this is the noble gas shorthand electron configuration for bromine. So now let's try our valence electrons for sulfur. If I see the phrase identify valence electrons, I should immediately think noble gas shorthand. Because if I can write the electron configuration in noble gas shorthand, I already know my valence electrons. So let's look. Sulfur on the periodic table, when it's neutral, has 16 electrons. The noble gas before it is neon. So I'm going to put neon in bracket. Neon has 10 electrons. So I've already counted my first 10 electrons. I can pick up after that. Electron number 11 gets me to sodium, which is in the third row of the periodic table in the S block. And I can fit 2 electrons there. After that, I have to go across to the P block, still in the third energy level. And I have 4 electrons left, which will all fit into 3p.